In today's lesson, we're going to learn about the mole and how it relates to mass. In the last unit, we learned about the mole, what it was all about, and how to make connections between mole and the number of atoms or molecules or formula units in a particular compound. So today you're going to need to have your periodic table handy. If you don't have it already, make sure you grab one. And we're going to use it to learn about the connection between moles and mass. So first thing we need to learn about is something called molar mass. Basically what that is going to represent the mass of whatever you're working with, atom, formula unit, compound, and it's going to express it in units of grams per mole. So that means we're going to look at whatever the mass is of your substance in grams, and it's always for 1 mole, or we say per mole when we look at our units. This is the international unit, the standard international unit for amounts when dealing with chemistry. So this is something that's used all over the place, and it'll help us make a connection with a unit we're familiar with, grams, and connect it with moles, which is something that's still new. So what we'll do first is we're going to learn about how to calculate molar mass, and then we're going to try it out with some problems converting between mass and moles. So first thing that we're going to do is figure out how to calculate the mass of 1 mole of a substance. So the substance we're going to try out is calcium phosphate. We already have the chemical formula for the compound. If you're only given the name, you need to have the chemical formula to make sure you know how many atoms of each element you have, because that's important in your calculation. So how do we do that? We have to find the mass that each element contributes and make sure we adjust for how many atoms are in our formula. So first, if we look at calcium up here in our formula, you can see that there's a 3. So that means I have 3 atoms of calcium. But what is its mass? So I'm going to go and look on my periodic table, and I'm going to look for the mass of the compound. So take a look on your periodic table. And I'm just using the values from our generic periodic table. When you go and find it, you should see that calcium has a mass of 40.08, and we're going to put in our units now of grams per mole. Okay, so we've got 3 atoms of calcium. Each of them have a mass of 40.08. So now what you can do, pull out your calculator or do the math in your head. This number is not too bad. 3 times 40.08 will give you 120.24, and that's grams per mole. That's the total mass of all the calcium in calcium phosphate. Then we need to repeat the process with the other 2 elements that are there. So we've got phosphorus and oxygen. They're listed here already. And so we're going to do the same thing. How many atoms of phosphorus do I have? There's a 2 here outside the bracket that multiplies anything inside. So that means I have 2 phosphorus atoms. And then we're going to do the same thing. Go to your periodic table and have a look. Once you found that mass, you should see that it's 30.97 grams per mole. And again, do the same thing. We're going to multiply it by 2. And this gives us a number of 61.94 grams per mole. Then if you want to try one out, pause the video and see if you can figure out what the mass of the oxygen should be. So pause it, try it out, and when you're ready, come back and press play. Okay, so when you have a look at the formula up here, there's a 2 on the outside and a 4 with the oxygen on the inside. That means we have to multiply. 4 times 2 means we've got 8 total oxygen atoms. Each oxygen, if you saw on your periodic table, is 16. So that's 16 grams per mole. And when we multiply that, that gives us 128 grams per mole. Once you've done this for whatever compound, formula, whatever you have, for each element, what you want to do is add them all together. So take a minute now, and in your calculator, 120.24 plus 61.93 plus 128. And when you get that, you should get a grand total of 310.18 grams per mole. Now you might have noticed over here on the side, we're using a different symbol here for molar mass. For molar mass, we're going to use the symbol of capital M. That's pretty standard. So lowercase m is for just regular mass, and when you see the uppercase M, that's for molar mass. Now, remember how we've been working with ratios and units? Your molar mass here is actually expressed as a ratio. So your ratio here, you could say, is 310.18 grams per 1 mole, or you could have it flipped around left and right, doesn't matter. But when you write that out in a fraction, you can get two ways you can use that for our calculations. So we could say 310.18 grams over 1 mole or per mole, or your ratio, you could write it the other way around, 1 mole for every 310.18 grams of calcium phosphate. So once you've done a few calculations with molar mass, it's pretty easy to do. I think it only takes a couple of questions to realize how you need to calculate it. So once you get a little bit better, you don't need to show all of this work here that we just did, but that's the process for doing it. So you can always double check all of your work. And the place where people usually make mistakes is counting the atoms. So just make sure you know your formulas and you know how to count atoms, and then you should be okay to proceed. So now that we know how to calculate molar mass, what we're going to try and do is actually a calculation. So we want to convert from a measurement of moles to a measurement of mass. So this question says a flask contains 0.75 moles of carbon dioxide gas. What mass of carbon dioxide is in this sample? So if we see a measurement in moles, what does that actually mean for mass? Maybe we can relate to that a little bit better. So let's start by writing down our givens. We've got a measurement for moles, and if you remember, moles is that lowercase n. So we've got 0.75 moles. We have a specific formula, carbon dioxide. We'll come back to that in a minute. And then the question's asking us, what is the mass? That's our unknown. If they don't give you units, just assume that it's going to be in grams. Some questions will ask you to put it in kilograms or maybe milligrams, but if it's not specified, you're pretty safe to say that your answer should be in grams. So anytime you see a question with mass involved, you have to probably think I'm going to need molar mass. So just as a side note over here, the question's basically saying I have moles and I want to find the mass. Anytime this happens, you need to use your molar mass to convert. That's your big M. Now, did they give us the molar mass in this question? You don't see any other numbers there. So the numerical value isn't given, but since we know that we're dealing with carbon dioxide, this is something that we can calculate. So in a question, they generally won't give you the molar mass, but if you know the compound, you can get a chemical formula and then come up with the molar mass for yourself. So just for extra practice, pause the video for a moment and see if you can calculate the total molar mass of carbon dioxide. So pause and give it a try. After you've checked our answer, make sure it matches with mine. So your molar mass here should be 40.01 grams per mole. That's the mass of 1 carbon and 2 oxygen atoms. Now we can start to solve the problem. Remember, the molar mass is just like a ratio. So we're going to start off our problem with what we're trying to solve for, which is our mass. And just like before, always take a number you're given. Here, our number that's given is up here, that 0.75 moles. And just like before, we're going to use our ratio or a fraction to try and do our calculation. So again, two ways of looking at it. I have moles in the numerator. I want to eliminate moles, so I know my moles have to be in the denominator. Or the other way of looking at it is I'm trying to find the mass, so I want my units that I'm solving for on the top, which is grams. Now that we know we want moles and moles to cancel, and we're left with grams, then we can go and look at our measurement here. How many grams do we have? That's our molar mass, 44.01. And it's always per mole, so that always means for 1 mole. So now in your calculator, you're going to do 0.75 times 44.01 and divide by 1, so we don't really have to change that, and then we can cancel out our units. So again, pause, see if you can come up with the answer, and for practice, round it to the correct number of significant digits. Okay, now that you're ready to check, you should get 33.0075 grams as an unrounded answer. And when we round, if we look at the numerical value given in the question, 0.750 is 3 significant digits. So in my answer down here, I need to make sure I round to 3. So 33 point what? It's a 0 here. Adjacent to it is a 0, so it's going to stay as 33.0. So that's how we calculate from moles to mass using molar mass. Now we're going to try out another problem going the other way around. So I'm going to help you get it set up, but I want you to try this one out a little bit more on your own. So this question is saying how many moles of acetic acid are in a 23.6 gram sample. So this time, our unknown, how many moles, is what we're trying to find. We're given a mass, 23.6. So again, this is similar to the last problem. We're going from this time, we're trying to find moles, but instead, we're flipping that arrow around. We're starting with mass. It doesn't change your problem solving process because you still need molar mass. So this time, instead of going moles to mass, we're going mass to moles, and we do that with molar mass. So what I want you to do now, pause the video and see, can I calculate my molar mass? And once you've done that, try and see if you can set up the problem and solve. Okay, hopefully you've given a chance to try both molar mass and the number of moles. So here, my molar mass, when I calculate, should be 60.06 grams per mole. Now looking at the formula, you can see there's 2 carbons. So I have to have the mass of 2 carbons. There's 2 oxygens here, right here and here. And then there are 4 hydrogens. 3 plus 1 is 4. So when we add all that together, it should give us 60.06. Now we're ready to set up the problem. So if you haven't tried it already, I would pause and try, but hopefully you have. So I do the same thing as always. Start with what I'm trying to solve for, which is moles. Put down my given value from the question. The only number I have is 23.6. And again, always multiplying by a ratio or relationship. This time it might look a little bit different. Here I've got grams in the numerator. I don't want grams, so I need to make sure my grams go in the denominator. They'll cancel. Or again, the other way of looking at it, I want to end up with units of moles. So the units I want to end up with need to go in my numerator. So now when I go back and look at my molar mass, I'm going to put my 1 mole on top and my 60.06 goes on the bottom in the denominator. Then in our calculator, all you have to do is 23.6 grams times 1, doesn't change the number, and then divided by 60.06 grams. Grams and grams cancel, and you should get somewhere around 0.39294 moles. And when we round that to significant digits, how many do we want? Always go back to the question, 23.6. That's 3 significant digits. So you want 0.393 moles. So hopefully that gave you a little bit of idea now of how to calculate both molar mass and to try and do some calculations between mass and moles. The second part of our second part of our lesson is the remaining few slides in our notes. So those ones will be work for next week. You can definitely look ahead, but next week what you're going to do is end up putting together calculations with mass, moles, and the number of particles. So make sure that you know how to do both mass and mole calculations and mole and particle calculations separately, because next up we put them both together.